So let's look now at part one of transforming graphs. And what we're going to do in this section is we're going to apply both a vertical translation and a horizontal translation to a function and its graph. So let's start with a vertical translation. And when we say a vertical translation, what we're talking about is moving the graph up or down. Translation vertically means up or down. And the form we're going to look at is this form of a function is going to become clear as we work our way through. So let's look at this first function, one we already know, a square root function. And if you remember the graph of a basic square root function, the graph looks something like so. There is the graph of y equals root x. And we want to compare y equals root x to this new function of y equals root x minus 2. Now, what we're going to do this first time is we're going to do a table of values to show what happens to this function when we put in x values, see what we get for y. If you remember the points we put in for a square root, 0, 1, those perfect squares, 4, and I am going to include 9. And now we need to put our values into that square root and solve for y. What we would be doing here is we take our first x value of 0 and then minus 2, and obviously we're going to get an answer of negative 2. If we were to put 1 into the square root of 1 is 1 minus 2, we get negative 1, just plugging those x values in. 4 in there, square root of 4 is 2 minus 2 would give us 0. And we put 9 in there, square root of 9 is 3 minus 2 is 1. These are now our new translated points for our graph. So let's see what happens to our graph when we plot these points. We go 0, negative 2, there's our first coordinate. 1, negative 1 is our second coordinate. 4, 0 is our third coordinate, and because we got space here, we'll go out to 9 and 1. It's right here, and there's our points. We still have the same shape of that square root, and there is our translated graph. Now what we can notice about this graph is that it's been shifted or moved down in this case. And all we've done is change that negative 2. Let's keep that in mind as we do another translation, another shift. This time with the absolute value. And again, remember your basic absolute value graph, that's that V graph. There is our absolute value that we're going to compare it to. That is the graph y equals the absolute value of x. Well, what happens if we add 3 to that absolute value? We want to find out what is this going to do to our graph. Well, let's plot some points again. We'll do this the first time so we have an understanding. Well, let's put in our points for an absolute value, and I'm going to go negative 2, negative 1, 0, 1, 2. Remember, we can choose any points, but those make the math easier. If we solve this now for y, our first coordinate, we take the absolute value of negative 2, add 3 to it, which of course becomes 2 plus 3, which is just 5. And that's the calculation we're going to do for all our points. At negative 2, now we're going to be at 5. Absolute value of negative 1 is 1 plus 3 puts us at 4. Absolute value of 0 is 0 plus 3 puts us at 3. Absolute value of 1 is 1 plus 3 is 4, and we can probably start to see a pattern here. Absolute value of 2 is 2 plus 3 puts us at 5. And here are our new coordinates for this absolute value function. Well, let's plot these points. Negative 2 and 5 puts us right here. Negative 1 and 4 There's -1 and 4 there. 0 and 3, 1 and 4, and we can probably see already what kind of translation has occurred. If we were to connect those dots and get that V graph, we can see now that we have been moved up. That +3 moves it up. And in this case, we can actually see all the points have been moved up 3 values. And that's the relationship for a translation for the k value, the number outside the function. And if k is positive, what we say is we have a vertical translation, and we do need to state the direction, vertical translation up, and the value we move it up would be k units. K units meaning 3 units or 5 units or 7 units, whatever the value of k is. And of course, the opposite would be true if we had a negative k value. This is going to give us a vertical translation, now this time not up, but down k units. And that value of k, whether it's positive or negative, that's going to determine whether it's going to go up for positive or down for negative. So let's put this into practice in an example. Here's a function. We don't have an equation, but we have a picture. And we're going to take this function y equals f of x and describe the transformation applied by f of x minus 2. And once we describe it, we're going to map the coordinates to create a new graph. Well, we can look back and see that minus 2, a negative, tells us we are moving down. So if we were describing this translation, this would be a vertical, and we do need to use proper vocabulary, a vertical translation. This time, because it's negative, we're going down. The value of k in this case is 2 units. There's our description. That's how we would describe the transformation. Vertical translation down 2 units. Well, now we want to map the coordinates of the image points. And by mapping the coordinates, what we're going to do is take coordinates that exist on the original graph, and we're going to use those points that are circles, and we're going to map them to their new place, their new point. Well, the first coordinate there is the point -6 and -5. And if we were going to map it, and we often use this arrow for mapping, we're going to take that point, and our translation tells us to move it down 2 units. So just take the point, drop it down 2 units. That new coordinate would then be, notice we haven't changed the x, -6, and if we go down 2 units, now we're at -7. And we can do the same with the other coordinates. So there's the list of the original green coordinates, and if we were to drop each of them down 2, that would tell us the new coordinate on the graph. And it's pretty easy to see these new coordinates keep the x the same and just drop the y value. So we can now map our new coordinates. Like so. Notice how all the y coordinates we've just subtracted 2. Now once we have the coordinates mapped and we have the coordinates drawn, we can now just connect our dots and get our new function that has been translated down 2 units. So what about horizontal translations? And horizontal translations, this time we're shifting the graph either left or right in the horizontal direction. And we're going to do this example using a function we know, our quadratic function. And remember, our basic quadratic function looks something like this. Remember, from the vertex, easiest way to graph a quadratic, over 1, up 1, over 2, up 4 in both directions. And there is our basic quadratic function, and we're going to keep that in green, of y equals x squared. Well, what happens if we were to go now in red and draw a new quadratic function? And if you remember from grade 11, this new quadratic function is now going to have a vertex at 3 and 0. Once we have the vertex, then we can plot our points following our pattern from the vertex over 1, up 1, over 2, up 4 in both directions. We get our new quadratic, and we can probably already see which direction that has moved. This has now been shifted to the right. Well, what happens if we were to add 2? And again, adding 2, remember our new vertex is at -2 and 0. So here's our new location of our vertex. Following our pattern, we can easily create our quadratic function, connect the dots with that parabola, and we can see now we have shifted the graph to the left. The only difference between these two graphs is the positive and the negative. And so now what we can tell is what happens to the h value, the number inside the function, and how does that relate to a translation. Now what we do have to be careful about here is the notation. Y equals f of x minus h. We may also want to think about this in this form. Y equals x minus, think of the h value as completely separate from that negative sign, because now if the h value we put in here is positive, we are going to get a function that has inside the brackets a negative sign. And if h is negative, we put a negative inside those brackets, the brackets will have a positive sign. So it's opposite to the sign inside the brackets. Now, if we do have a positive h or a negative bracket, that tells us it is a horizontal translation. And this time, the translation is not up and down. That's why it's horizontal. It's a horizontal translation, h units, and if you look back at the quadratic, h units to the right. So a negative sign inside the bracket tells us we're moving to the right. And of course, the other one, if we have a positive sign, it's still going to be a horizontal translation. But this time, it'll be h units, not right, but left. So positive tells us left, negative inside the brackets tells us right. That's an important piece to remember. Let's put this into practice with an example. Here's our function, f of x. Remember, f of x is that original graph. We want to describe the transformation applied when we have this transformation and then map the coordinates of the image points. Well, first of all, as soon as we see it's inside the brackets, we know that this is a horizontal translation. Because we have the negative sign inside the bracket, that negative sign is going to tell us the direction of this translation. It's 2 units to the right. 2 units right because it's negative. So all of our points, they don't move up and down this time. They just move over 2 units to the right. And this one's going to go off the graph, but that's okay. There we go. 2 units to the right. As we did before, we can now map these coordinates. So take a second right now, pause the video, see if you can map these coordinates on your own. So here's our original coordinates, and there's our new mapped coordinates. Well, notice in our mapped coordinates, only the x value has changed. And all of those x values have increased by 2. 2 units to the right increases it by 2. So once we have the new coordinates, now we can just connect the dots. And what we have is our new function translated horizontally 2 units to the right. And we're going to look at more examples like this in class.